Hey guys, what's up? What's up? Let's take a look at this. Over here is this is going to be our first lab, which is going to be your save as. This is going to be your Flex VPN lab. All right, the plan today is to take a look at Flex VPN. We're going to take a look at two setups. As I had told earlier on in the chat, we're going to be taking a look at, let me change the format, the font over here. We're going to be taking a look at your site-to-site Flex VPN. We're going to have DVTI, Dynamic Virtual Tunnel Interface on one side, SVTI, Static Virtual Tunnel Interface on the other side. We'll also take a look at spoke-to-spoke, which is very similar to your DMVPN setup. Spoke-to-spoke communication using NHRP redirect and all that type of stuff. Anybody need record permission before I get started? Prithvi and Santosh, I've given you guys the record permission already. Issue I've given you. Eid Mubarak, Santosh. All right, so everybody should have record permission right now. Once we're done with that, once this part is done, we're going to take a look at our ASA firewalls, at least do the basic configuration today. Our objective today is to take a look at interface configuration, security levels. We'll take a look at routing. Routing is RIP, EIGRP, and OSPF. I think that's where we'll stop today. So please get our ASA firewall in over here. Okie doke. That's the plan. If I see there's more time to do more stuff, we'll do more stuff. In terms of the outline, let me see where the outline is. So the only two things that are left over from this part over here let me bring my I'm going to start with this DVTI, SVTI, site to site, and then we'll take a look at spoke to spoke. You need to pay attention. This is very important and tricky. Once this part is done, we'll get into the firewalls ASA, interface config, security levels. We'll take a look at management as well. Routing RIP, version 2, EdgeRP. This should be OSPF. And we'll also run BGP. Well, BGP we'll do later on, but at least run the 3 basic IGPs right now. Once this is done, we'll probably call it a day over here. And then next time around, we'll take a look at your NATs, access policies, we'll get into transparent firewall, and get into redundancy after that. Good, everybody? Ready for flex? So the topology that I have today is this one. The first VPN that I want to do, let's say I'm assuming this. Hi, Mahim. Who are you logging in through? Did you contact me or Vikas? How did you come in? While you answer, my first VPN over here is going to be over here. Okay, I need to make it bigger. How do I make this size bigger? Oops. Solid line is our size. There you go. Still not that big. It's okay. So my first VPN is going to be between the hub over here and this is going to be my first spoke. Spoke 1. The thing is, this guy over here does not have a static IP. It has a dynamic IP. So rather than doing a normal VPN where I do what we did the last time around, where I pointed SVTI, a tunnel interface with the tunnel destination of this IP, I'm going to do it dynamically. Once you guys see that setup, I'm going to use the same type of setup in my other VPN, which is going to be your spoke-to-spoke VPN, where I'm going to do it between 1, 3, and 4. 5 I'm not using today. So again, let's change the size of this guy over here. This is the biggest you can get. This is going to be my second VPN, which is going to connect hub and these two guys into one multi-point VPN, where hub R3 and R4 will be part of one network. So the purple network is going to be, let's say, 192.168.134.0 multi-point network, whereas this guy over here is going to be, let's say, 192.168 call network on the private side. All right, that's our plan. Those are the two type of VPNs that we're doing over here. All right, mine, just hang in there for the VPN section because we're towards the fag end of the VPN lecture. Once you start with the ASA, everything will be from scratch. So just hang in there for the VPN part. When I cover the next course, I'll get you started with VPNs from scratch. So for right now, you might not understand it because it's advanced level. But right after I'm done with my VPNs, I'm going to start with the ASA firewall. So you should be at home over there at that point. All right, mine? Okay, so with that in mind, let's go get started. The hub to R2. I want to do a normal site-to-site VPN. I'm going to start with R2. The IP addresses, the public IP addresses that I have on these networks. These are my tunnel IPs that I showed you. At the same time, I have public IPs over here as well. Public IPs on these networks are 192.1.20.0. Oh, sorry, 10.0 over here. Okay, this guy over here, 20.0. These are public addresses, so you guys know what they are publicly. And this guy over here is 3.0. I'm not going to use the other one. That is that R5 I'm not using in our example today. So this is my setup. I want to set up a normal SVTI from spoke 1 to hub. Spoke 1 is router 2 towards R1. How would I do it, guys? You guys remember IQ2 from the last time round? Let's do that over here. So right now I'm doing Flex VPN, site to site, where one site is DVTI, and I'll explain what DVTI stands for, and SVTI. SVTI, you guys know already, that's the static virtual tunnel interface. You guys remember how I did our normal IQ2 SVTI tunnel from the last time around? Yeah? So if you guys remember, in my first step, I had 4 sub-steps. This is phase 1, using IQ2. First step, step A, is configure the proposal. Do you guys remember that? Crypto IQ2 proposal, let's call it prop 1. Integrity, let's say MD5. Encryption, use triple DES group 2. Everybody okay with this? You guys remember that? For example, if I had group 2 and space 5 over here, what does that mean? It's going to create all the different combinations over here. Or if I had MD5 and SHA-1, it would create MD5, triple DES. So in this case, if you guys remember from the last time around, that was the advantage of doing the proposal, is it's going to create multiple policies for me. What are the policies going to look like? One policy is dynamically going to create is MD5, triple DES 2. It's going to create another one, MD5, triple DES 5. Then it's also going to create SHA 1, triple DES 2, SHA, triple DES 5. So it's automatically going to create all the different possibilities based on the different sets that I've set up over here. Everybody okay with that? Yeah? Step B, do you guys remember? Get your notes out if you don't have them. Configure policy. Crypto IKE V2 policy, let's call it Pol 1, call the proposal. Step 3, configure the keyring. Crypto IKE V2 keyring, KR, let's call it 12, between 1 and 2. All right. Here, R1, address 10.1, because I'm doing this on R2. Static virtual tunnel interface. Pre-shared key, PSK, I'm going to say Cisco 12. Good so far? Or just use a common key, 1, 2, 3, doesn't matter. And step D, all part of phase 1. Configure the IKE V2 profile. Crypto IP2 profile, whatever you want to call it. Let's call it prof 12, 1 and 2. All right. Match identity, remote address 10.1, authentication, local, reshare, authentication remote, reshare. All right. And the last thing, keyring local, followed by, what did I call it? KR12. Good. This is your phase 1. I'll copy it. Actually, did I start my routers up? Yes, I did. I now need to open up my secure CRT. Okay. Connect. Router 6, by the way, is the middle router, the internet router. I think it's pre-configured. I have the initial config already on it. Yeah, 10, 20, 30, 40, 50s, and IM.6 on all these networks. What the, okay. 1. I need to do router 2 right now. Show IP interface brief. The 10.2 network, 20.2 is my IP on the Ethernet. Show IP route. I should have a default gateway. Should be able to ping 10.1 my up. So with this in mind, I can go ahead and, okay. One second, guys. I'll just set the screen up properly. So I'm on router 2 right now. I can go to my notepad and copy my phase 1 over here. Looks like it took it. All the commands seem to be proper. Now phase 1 is done. What's next? What do you guys think I do next? In my next step. Phase 2, which is pretty simple, the transform set, right? Crypto IPsec transform set, let's call it T-set. ESP triple DES, ESP MD5, let's say 8 MAC. Step 3, configure, no, not ACL, this is the SVTI portion. So I'm going to configure the IPsec profile because I'm doing the SVTI. ACL would have been in case of what? If I was doing the crypto map version. I'm doing the SVTI version. So I just need an IPsec profile. Right, guys? Let's call it IPsec profile 12. Set transform set, T-set, set IP2 profile. I called it prof 12. The 2 commands inside the IPsec profile. Then I configure the static virtual tunnel interface. The reason it's called static is because I'm going to be specifying the tunnel destination. So I'll say tunnel 12, 1 to 2, for example. The IP address, based on our diagram, I set it to 12.2. The other one will be 12.1. Tunnel source, my public, and And if I don't know my public, I can always specify it based on my interface. So if I'm getting my IP address from my ISP, I'll say whatever IP address was assigned to my outside interface, just use that. Destination is 10.1, the hub. Tunnel mode, IPsec, IPv4, and protect it by using the iProf 12, the IPsec profile 12. So that basically means that anything that's coming over the tunnel interface should be encrypted by using this profile called iProf 12, which links it to the transform set and also links it up to the IP2 profile, which calls IP2 in phase 1. Last step over here. Configure the routing protocol. I'm going to run EIGRP because it's a little faster to run. Network is 12.0 and 10. So that covers step 2 through 5. You can go to router 2 now. Paste it. Looks good. The tunnel will stay down over here because I haven't configured the hub yet. Good so far? Everybody okay? At this point, I have not done anything that is new. Basically the same things that I would generally do on my normal SVTI to SVTI setup. So if I was doing a normal SVTI to SVTI, what do I mean by normal SVTI to SVTI? Basically setting up a logical tunnel interface connecting R1 to R2 so that I can route my networks behind these guys. Let's say 10.1.1.0 needs to be routed or tunneled to 10.2.20. I've set this tunnel up. The tunnel is running 192.168.12.0 as the network behind between them, 1 and 2. The tunnel will be encapsulated using IPsec from R2 to R1. But the problem over here is that this guy over here, let's say hypothetically, does not have a static IP. Instead, it has a dynamic IP. I know that the IP comes from this network, but I don't know what the IP is. It's static, so I don't know exactly what the IP address is over here. Everybody understand the concept over here? So I cannot create a tunnel interface over here. I cannot do this. I say tunnel 1, IP address is not an issue. Tunnel source is not an issue because I do have a static IP. The problem is tunnel destination. Tunnel source is not a problem because tunnel destination, I don't know exactly what that IP is. So over here, I cannot create an SVTI because that required a tunnel destination. I want to make sure everybody understands the problem over here before we move on. The problem over here is, although, yes, I know that I'm getting an IP address assigned to me from this range, I don't know what that IP is because that IP over here is dynamic. Because it's dynamic, over here in my tunnel destination, I cannot specify a destination. Understood? I'll show you how to solve it, but understand the problem before I show you how to solve it. Everybody clear about this? Yeses, please. Okay, so the way I solve it is by the use of what is known as a virtual template. It's a virtual interface. This virtual interface that I'll set up is going to be with all the parameters that I had, like what? The IP address, the tunnel source, tunnel mode, tunnel protection, everything. What is missing over here? What's the only thing that's missing? The destination. So I'm going to create this as a template. What's a template? Something that I can copy from. And I'm going to wait for him to initiate a connection to me. As soon as he gets an IP address assigned to him by his local ISP, he will initiate the connection to me. At that time, I will know what his IP address is, and based on this template interface, I will generate a new virtual interface, which will have all the characteristics that are inside the template, plus it will have the destination. This type of tunnel is always initiated from the spoke. The hub is just responding. So I'll create a virtual template interface where on the hub, as soon as this guy initiates a connection, I'm going to create a virtual interface based on that and the destination, pull it together, and I will have a setup. So in order to do that, I need to create this. What do I need to create? This virtual interface. All right. It's basically going to be a template. Based on this template, I am going to create the virtual interface when the user makes a connection. All right. I'll show you how to do it. But before we do that, let's go ahead and take a look at the commonalities. What are the different common characteristics that I have over here in setting this up on the hub site for the client? So this was on the spoke side. I'll copy this stuff because a lot of this stuff is still relevant. But then I'm going to put the differences over here. So this is going to be on router 1, which is going to be the hub, using this type of interface that is not created with the static virtual tunnel interface. Is called a dynamic virtual tunnel interface. Why? It's going to be created dynamically. Everybody okay with this? Yeah? All right. So with this in mind, what are the different things? Step 1 is still the same. It actually needs to match because I'm using the same parameters over there. I need to use the same parameters. Step 2 is the same. Okay. Configure the key ring. Call it KR2. Over here, I can say 20.0, 255.255.255.0. So I know it's coming from that particular network. I don't know the actual IP. Configure the profile, same thing. 20.0. All right. Yes, or you can use certificates. A better way of doing it is by using a certificate authority, so you can do it based on the host name. Because even if the IP changes, the host name remains the same. If you're not doing it based on that, then you need to specify at least a range that you know that this particular key is for this particular range of addresses, which is going to be the same for a range of addresses that you will probably get from your ISP. If not, then do it based on certificates and use the same host name to identify the client. All right, so let's do this over here. Now, notice over here in the keyring, one of the things that I need to add is my virtual template interface. I haven't created that yet. I'm going to create that template interface. Basically says when I authenticate the user and he gets validated properly, what I want to do is I want to create a virtual interface based on this template 12. And I'm going to create that template 12 that will have all those characteristics that I just talked about in terms of the virtual interface. I'll create that in a second. But just remember that inside your IQ2 profile, I do need to put the virtual template to specify if somebody logs in based on this particular profile, he is going to get a interface created based on this template interface that I'll have. I'll show you that. Once I'm done with the whole thing, I'll tie everything together. So phase 1, step A, B, C, and D, almost the same. So I'll copy it. Now this time around, I'm going to go to router 1, the hub, and start configuring it over there. All right, so let's do a run to see everything is there. Looks good. Clear? What's the only difference? The differences that you saw that I had to do on the hub site. Number one, it was not for specific addresses. It was for a range of addresses on both the keyring as well as on what? The match identity. And then I added the virtual template interface. I'll show you how that ties up in the next set over here. All right, good so far? So this is the main change that you have over here, besides the address. Phase 2, same. IPsec profile, same. No difference over there. Okay. Now, I don't create a static virtual tunnel interface over here. Instead, I'm going to configure a virtual template interface. This is what a dynamic virtual tunnel interface is going to be. I'm going to create this interface based on this template. What's a template? It's something that I copy from. So I'll put all the parameters that I need except for the one that is missing. That is the tunnel destination. So the way you create this virtual template interface is virtual template, give it a number. Now, if you take a look over here, I am calling virtual template 12 over here. So I should call it type tunnel. It's a tunnel interface. IP address. Now, this is the thing. In a virtual template interface, I cannot assign an IP address. I would ideally put it as 12.1, 255, 255, 2550. But the rules are a virtual template is a template. So it should not have an IP address assigned manually. So to trick it, what you do is you create a loopback. I'll create this loopback as 12, just a number, and assign the IP address that I want to assign to this template interface to this loopback. And inside your virtual template, I will call it saying, hey, listen, get your IP address from loopback 12. The reason for that, again, is in a virtual template, you cannot manually assign an IP address. So what you do is you tell, hey, get your IP address from loopback 12. And loopback 12 has an IP address of 192.168.12.1. If you guys remember, this guy over here was 12.2, so I'm setting the loopback to 12.1. So when the interface is created, it's going to be created based on that network 12. You guys understand that? People get confused over here. So I want to make sure everybody's on the same page with this. So because I cannot assign a manual IP under a virtual template interface, the way you get around that is create a loopback, put it on the same network as the one that you want this new interface to be created based on, and call it. So the new interface will have an IP address of 12.1. All right? Good? Everybody, yes, please. This is an important step. So I want to make sure everybody is on the same page with that. You understand the way I'm assigning an IP address to a virtual template interface? You cannot do it manually, so this is the way you get around that. Each time you get a new IP, it'll be added to the loopback. No, you're not getting an IP. This is for the tunnel interface. See, there's an IP address that is assigned. Dynamic IP that will be assigned to your physical. But your logical, which is the tunnel interface, will always have 192.168.12.0. This will always be .1. This will always be .12. So the dynamic IP is to the physical. So this loopback address is always going to be .1. You understand that? The only reason I'm doing it like this is because I cannot assign what? A physical IP to the interface. What will be added is the tunnel destination, because I cannot have a destination over here. Why can I not have a destination? Because I don't know the destination. So I'm going to get rid of that command. That's the whole purpose of the virtual template, because I don't know the destination. When he initiates a packet, he will have the destination, so I can pick it up. Tunnel mode, tunnel profile, all the same. So you guys understand what this virtual template 12 does now? It basically says when the user logs in from the 20 network and he authenticates properly, go ahead and create a virtual interface based on template 12. And template 12 says the IP address should be based on loopback 12, which is 12.1. The source should be E0/0. I'm on router 1, so it'll be 10.1. Destination, find it. Find it to where? Wherever the packet came in from. Mode is IPsec, IPv4, the SVTI, DVTI portion. The protection should be based on IPv12, which is this guy, the profile, and then run the routing. The routing will run on the tunnel and the internal 10 network. All right, so let's do phase 2. Loop back, create the virtual template, and run routing. Copy. Go to router 1. ISACamp is on. It should start setting it up. Unless my IP is do debug IP2. Make sure. Might be the IP address on the key. That sometimes is an issue. Some of the iOSs don't like the 255, 255, 2550. I'll try to see if that's the case. Looks like it went up. Yep, it just took its time, but now it's okay. This iOS is okay with that. Show IP route, EIGRP. I've learned the 10. Now, if I go to route 1, show IP route, EIGRP, I have the route in there. Show IP interface brief. I want you guys to take a look at it. The virtual template is not a real interface, it's just a template interface. It'll always remain down. But based on that, I have created a new interface called what? Virtual access 1, which is 12.1. You see that? To check the interface itself, show interface virtual access 1, you will notice that it has an IP address, source of 10.1, destination 20.2. 20.2, it found out when the router 2 initiated the connection. Does that make sense, guys? So the flow of steps or flow of what happened was This device over here got an IP address dynamically assigned to him by whom? From R6. Okay. The IP it got was, let's say, 192.1.20.2 or whatever from the 20 network. As soon as it got it, because it has that the tunnel interface created as a static VTI, as soon as it has the interface come up, E0/0 comes up, it will initiate the tunnel from router 2 towards router 1. When it initiates the tunnel, it says, I want to authenticate myself. My IP address is 192.1.20.2, specifies the password, which matches. Because it matches the password, it will say, oh, I need to create a virtual interface for him based on virtual template 12. So it creates a brand new interface over here called virtual access 1. Creates the interface, sets the IP address up, runs routing over it. And from that point on, it's just normal SVTI, DVTI. You understand that? So although I did not have a static IP address assigned on one side, it still worked because of this virtual template concept. Everybody okay with this? Any questions on this? You need to have one side with static IPs, just like in, what do you call it, in DMVPN. At least one site, the hub site, needs to have a static IP. It is hub and spoke. We will do hub and spoke, but the hub itself needs to have a static IP. What if the IP address changes on what? Router 2, you mean? Yes, it will bring the old interface down and bring the brand new interface up. It will be called virtual access 2. You guys understand that? It's still the same that we did. The only difference is now there's this concept of virtual template that you need to be aware of, and you need to tie up the virtual template to the IP2 profile. Clear, guys? Everybody okay with this? All right, brilliant. My question to you guys over here is this. Let's say this is my internet, router 1, router 2, I have this type of setup. If I do this, continue on doing this, it's going to create multiple what? Point-to-point interfaces on router 1 based on the virtual template. I can do that, not a problem. In terms of the drawback of this type of setup is that if router 2 over here wants to talk to router 3, it's a point-to-point tunnel between R1 and R2. So the traffic will go through hub and spoke. If that's what you want to do, you can keep on adding 2, 3, 4 in the same manner. They'll be created in a hub and spoke environment. But hub and spoke not only for the purpose of what? For control plane, it's also going to be hub and spoke for data plane. If that's what you want, it's okay. That's what you're going to get. You can do that. But what if you wanted to do communication between the spoke to spoke? Directly between R3 and R4. Remember that DMVPN type of setup? What protocol did that mapping for me? You guys remember that? NHRP, right? I can run Flex VPN to also support that. So it can support different things. If you want, let's do that over here. Let's do one that is static. So I did one that was what? Dynamic. This guy over here was what? This was DVTI, Dynamic Virtual Tunnel Interface on this side. He created an SVTI because it was pointing to a static IP. Let's say R5 is there, and I want to do a normal site to site, where I have what? Sorry. SVTI on both sides, the simple one. Why? Both sides have static IPs. Let's do that real quick. So we can see the variation of the things that you can do with Flex. So let's put that over here as well. Put a different color. Let's say orange. Orange is going to be the IP. Oops. So this is going to be normal static. So this one, I'm going to assign a IP address of 192.168, let's say 45.0, or not 45, let's call this 1 and 5, 15.0. Not necessarily. Virtual template I can also use in frame relay. The flex concept is I can do different type of things, flexible. I can do different type of tunnels using the same type of setup. That's the flex part of it. Virtual template is a very old technology that allows me to create a template interface that I can use for different things. If you've done frame relay has the capability of doing a virtual template as well. So virtual template doesn't make it flex, but the capability of doing different type of VPNs using the same overall setup is the one that makes it flex. So that's why I'm doing this over here. This orange one is going to be static to static. So this guy over here, I did it as dynamic DVTI to SVTI, not the orange one. This was this guy. The orange one I am going to do as what we did the last time around. So this is not new, but I want to do this so that you guys can see that I can also do this over here. This is going to be between what? 1 and 5. So I'm going to utilize 1 for that, 5 for that. So go to 1. Actually, I'll use this notepad over here. On 1, copy. Actually, I'll copy 2 because 2 is more like what I need to do on between. This is static VTI to static VTI. R1. Now on R1, I already have Phase one done. These two parameters are done already. So I don't need to redo it. I can get rid of it. I can start with step C. So I'll say step one, phase one, because that stuff is common. The top two, I'm going to use the same parameters. So this one will change. I'm going to call this 1 to 5, which is 15. This is R5. The address over here is going to be 50.5. Password, I'm going to keep it the same. Profile, we'll call it 15. This is where the client also has a static IP. So both sides have static IPs. So this is also 15. Phase two, I'm not going to do. Why? Because it's already done on based on my earlier config. IPsec profile, I'm going to change it to 15 to use 15. My SVTI tunnel, I'm going to call this 15. IP is 15.1. I'm on router 1. Source is 50.5. No, I'm on router 1. Tunnel source I got, tunnel destination I needed to put. Sorry. So this is okay. My destination is 50.5, router 5. My profile is 15. My network router, EIGRP, I have the 10 already on router 1. I'm just going to put the 15 network, the new one. So I just added the new commands to my existing config to accommodate what? R5. So copy it. Let's go to router 1. This is going to be for R5. Just make sure all the commands took. Ring R5, 50.5, profile 15, 50.5, KR15, IPROC 15. Looks good. 15.1, 50.5. Everything looks good. Now that this is done, we will go ahead and do the same thing for R5. This is static. So I'll just copy R2 and make the changes. So this is R5. Because R5, I'm doing it from scratch, so I need phase one and phase step A and B. This guy will point to 1, but I'll say 15. The IP address remains the same. Let's call it 15, so it's proper. 15. Interface, I'll call it 15. This needs to be 15.5. Profile is 15. The routing protocol is 15. So this is going to be on R5. I would definitely use Notepad. This really helps in terms of the configs. And because it's static, it immediately comes up. Now I have 10.2 and 10.5 on router 2, router 1. Router 2 has do show IP route EIGRP. I have 10.5 as well, so I can go to 10.5 from 10.2. So 2 can go to 5. So right now, this is hub and spoke, by the way. This is DVTI. Here is SVTI. So whether I have dynamic or static, I have the ability to accommodate both type tunnels. Everybody good with Good so far? But this is going to cause a hub and spoke type environment. R2 wanting to talk to R5 will need to go to where? To router 1 down over here. So if this is Dubai, and this is, let's say, Singapore, and I want to go to Sydney, if you know your world map, Singapore will come to Dubai before it goes down to Sydney, which is suboptimal forwarding. Good so far, guys? Everybody okay with this? You need to do the practice on the commands, but I want you guys to make sure you understand the concept over here. Yeses, please. All right, brilliant. Then enough people to go ahead. So now what I'm going to do is I'm going to set up this setup over here if it required, based on the requirement that I want to do what? Direct communication. If I had to set up a direct communication between R3 and R4, how would I do it? Using NHRP. This is a little complicated. This type of setup is complicated. I'm also going to show you another thing over here. Do you guys remember that I have the ability, I gave this IP, the tunnel IP over here, manually, IP address, and I specified what? X.X.X.X, which was 192.168.12.2. One of the things that I can also do through NHRP or through Flex VPN is even the tunnel IP of these spokes can be pushed down from a pool over here on R1. So I'm going to create a pool over here. Let's say 192.168. We'll say 134.0. And from that pool, I'm going to push IP addresses to whom? To the tunnel, to 3 and 4. So they don't create a conflict between the different devices. All right. So the first thing that I need to do, if I want to do something like that, I need to create what is known as an authorization policy for this. This is your NHRP tunnel that I'm creating. Okay. This is done only on the hub side. The other thing that I also want to do is when I do NHRP and I do a next hop and the next hop gets propagated to my clients, I need them to also send down their interface IPs, whichever have been assigned to them, to each other. So they have reachability to each other so that the NHRP can work. Those are the two things that I need to do over here. So the first things first, over here, I need to set up this configuration in such a way that it assigns an IP address to the client tunnel interfaces, also advertises those tunnel interface IP addresses to each other, so there's full reachability between the clients. That is done by using these commands. So I'm going to put these commands over here first, and then we'll copy it over here. This is your spoke to spoke. Okay, this is all done on the hub right now. For this, I need AAA new model. I'll create a authorization network default list and point it to local for authorization. As I'm assigning IP addresses down, I need to have authorization done for AAA. So first thing that you need to do is enable AAA for this, for the pool assignment. Then I'll also need to create a crypto IQ2 authorization policy. I'll call it NHRP. You can call it whatever you want. Inside here, I'm going to assign the pool. So over here, the first thing that I'll do is I'll create a pool. I'll call it Flex. I'll start the pool at 192.168.134.5 to 254. So the entire pool is reserve, call the pool, and I use this command route set interface. This allows me the ability to advertise whatever is assigned to that interface to the other guys on that tunnel, which is helpful for NHRP later on. This is just a name. So what's the whole purpose over here? This first step over here, configure AAA and policies required to propagate IP addresses to the tunnel interfaces of the client. That's what you're doing in this particular step, step one. So first thing that I need to knock out is that. Clear, guys? Everybody okay with this? So what am I doing with this? My tunnel IP, which up to this point I was assigning manually. Now on R1, I'm the hub. I'm going to assign the tunnel IP. I'm not talking about the physical IP of the interface. I'm talking about the tunnel IP itself. So even the tunnel IP, so I don't have a conflict, I'm going to assign both of them to the 192.168.134.x network. I'm going to create a pool over here and push that IP to the tunnel interfaces over there. That's what these commands over here are accomplishing for you. Understood? Authorization policy NHRP is reflecting to local. No, I'll call this later on. Local basically means default means anytime I need to push something, the default is automatically applied. The default is the list name over here. Local means use this policy over here, the NHRP policy. When the default says point to local, this is the local policy. Good so far? So I'll copy this and start it in this. So what are we doing over here? Spoke to spoke, Flex VPN. On R1, the hub. So what did I do over here? Configure the AAA policy, configure AAA, and policies required to propagate IP addresses to the tunnel interfaces of your clients, the spokes. Good so far? Now, normally I would do configure phase one. Now, on my hub device, don't I already have phase one created? Phase one in the sense of what? The proposal is created, the policy is created, right? I do need to create a keyring. I do need to create what? The profile. So this part needs to be done for phase one. But the first two steps are the same. I'm using the same parameters. So configuring phase two, phase one, I'm just going to do step C and D. I'll call this particular keyring 134. I'll say peers 3 and 4, 34. The address, I don't know their addresses because they can be a multitude of addresses. So I'll use a wildcard. Even my profile, 134, I'm going to put the address as 0000. Okay. Keyring is going to be 15. I'm also going to create a virtual template. I'll call this virtual template 134. Because again, these guys are going to log in, dynamic IPs. I'm going to create virtual templates from them, but I'm going to create a different template for them. Different IP, different network. Keyring again is going to be KR134. All right. One extra command that needs to be done over here. That is to link up that NHRP policy that I had created up front to this. How do I do that? What is the command to do that? AAA authorization, group PSK. My authentication is going to be done based on a pre-shared key, which is the KR134. All right. The list I'm going to use is NHRP. I don't have a username, so I'm going to use a username also as NHRP. This is the list name NHRP. So that's where it links up to the pool and the route set interface. It will also require you to put a username. I don't have a username, so put the same username as your list name. Because I can also use this for user authentication. I'm not doing that. I'm doing device authentication. So this is the one that tells my router that I need to push down what? An IP address to my clients based on this pool flex. Not only that, I also need to push my IP address, whatever IP address is on my tunnel, to my clients. It will go in as a static route. I'll show you that when we configure that. So these are the extra things that I need to do over here for doing a DMVPN type of setup. Number one, configure the parameters for your assignment of the IP address to the tunnel interface. I already have my phase 1 and phase 2 configured, so I'm not doing that. My key ring right now, I'm going to put it for what? 0000 because I don't know their IPs and they're more than one. And then the match identity is 0000. I use the proper KR, the key ring. Virtual template I'm going to create as 134, pointing to the authorization list of NHRP so that the IP addresses can be pushed down. Clear, you guys? Route set interface. So what it does is, because I need to do that NHRP mapping later on, my tunnel IP is going to be 192.168. What is it? 134 dot, let's say 1. Okay. This guy will get 192.168, let's say 134. The first one will get 5 because my IP address starts from 5. The second one will get 6. They're coming in from the pool assigned, right? Now, because of NHRP, I need those addresses to be reachable by everybody. A route set interface, what it does is he will send his IP address to him through the IPsec tunnel, not through routing, as a route, as a static route. It will be injected into the routing table over here as a static route. Similarly, he will send his route to whom? That's what the route set interface does. And I'll say go through the tunnel. Why is it required? Because the NHRP, I need to have the mapping for this IP. So I need that in my routing table. You will see that once I'm done with it. It'll come in as a static route. So on my clients, I still need to do what? The route set interface so he can push his IP address down to the hub. And vice versa. I would need to do it on the other guy as well. Good so far? Now, let's go copy the other stuff. That is my phase 2 to my routing. Step 3 actually now, because first one over here is replaced by AAA stuff. I don't need 3 now. Why not? Because on router 1, I've already done that. It's using the same parameters. 4, the IPsec profile, yes, I want to change it to iprof134 because I'm using a different profile. I'll call prof134 over here. So this one calls this guy, and iprof later on, I'm going to call it into my virtual template. Again, the virtual template, I'll do the same thing. I'll create a interface called 134, assign myself an IP address to loopback 134.1. I'll create a virtual template. What did I call the virtual template at the top that I was calling? 134. Call it based on that. Source IP is still E0/0. The profile that I'm using is 134. The routing, I don't need 10 because I've done 10 already, but I need to do 134 over here, the new network. So same steps towards the bottom. This is 6. This is 5. One thing though, I take that back. There's certain difference over here. Because I'm doing DMVPN, it's no longer a tunnel mode IPsec IPv4, it's NHRP. So I need to enable NHRP over here. So I'll say IP NHRP, network ID. If you've done the DMVPN class, you will understand this. Remember these two commands? I'll do a redirect as well as a enable of NHRP redirect. The actual mapping will be done automatically. So this tunnel interface that I'm creating is no longer going to be a IPsec SVTI. It is done based on your what do you call it? NHRP interface. So I won't call it a DVTI. I will call it a NHRP interface. All right. Subtle differences over here. So I'll do it one step at a time, small steps. First thing is set it up so that I can copy my assign IP addresses to my interfaces, router 1. So copy. So this is the one that will assign IP addresses to my clients. Second, I'll create my phase 1. Again, A and B are done. So I'm doing 3 or step C and step T together. Copy. I just want to do it in small steps. So if there's an error, it picks it up. Looks like it went through okay. Phase 3, I don't need to do because it's already done on this guy. Or step phase 2, I don't need to do. Step 4 is the profile, which is the new one that I created, and that virtual template interface. I'll do those two commands together. And the last thing, reconfigure your routing protocol. I need to add this new network that I just introduced. So I can run EIGRP on it. This is on what do you call it? Hub site. What about on the spoke site? What do I need to do on the spoke site? Let's take a look. I'll copy the whole thing and then make changes accordingly. I'll just do one for right now, router 3. Once router 3 is working, we'll go and do router 4. Router 4 then becomes easy. R3 spoke, configure 888 to propagate IPs. So what I need to do over here is I don't need to create the pool because I'm getting the IP address from where? From the hub. So I don't need a pool over here. I don't need the pool flex, but I still need to do the route set interface. Why is that? You guys remember I told you that. The purpose of the route set interface is to do what? Push my interface IP to the other guy because I need that for my NHRP mappings. So I still need this AAA stuff so that I can do that route set interface required. Step 2, I need to do phase 1, but phase 1, this is a client, so it does not have any proposals and policies. So I'll just copy it from here because I'm using the same on all of them. Copy it. So over here, proposal and policy. Key ring, I'm going to use the same, 0000. IK profile, I'm going to use the same. Now, subtle differences over here. When I create this template over here, the template interface, one small thing that you need to worry about. This part is okay. But when I get to the point that I'm going to be doing the tunnel interface, you'll see some differences over there. So this guy, the template interface, it'll be different. So over here, I'm saying the virtual template is 134, which is fine. This is all the same. I do need to have this, so I will undo my remark over here. This is okay as well. The difference is now, first of all, I need to create a tunnel interface. All right. The tunnel interface that I'll create IP address, I normally would have said this, or 15 dot, let's say this is 3. But here, I'm not going to do that. I want the IP address to be negotiated. What does that mean? Get the IP address from the server. Tunnel source is going to be E0/0. Tunnel destination is going to be 10.1, my hub. Then I enable my NHRP on this because it's not a IPsec interface, it's an NHRP based interface. And then if he sends me a redirect, what do I do on the client side? Do you guys remember? If you remember from DMVPN, if NHRP sends me a redirect, what do I need to have on the client side? Do you guys remember? Shortcut, absolutely. So I'll say IP NHRP shortcut with one subtle difference. What I want to do with a shortcut is actually create an interface between me and the other guy. So I'm going to say, I want you to create a shortcut based on this virtual template interface called 134, which I'm going to be creating in a bit. And then this is done. The last thing, tunnel protection, IPsec profile. What did I call it? iProf 134. So I create this tunnel interface over here. I'm pointing, it's like an SVTI. I'm creating towards what? Towards a server. The server has a DVTI type. But the only thing that I'm saying is when I get a redirect, I also want to create an interface directly from spoke to spoke. That is what the shortcut does. Based on this virtual template interface 134. Now 134, what I'm going to do over here is I'm not going to create a loop back. Instead, I'm going to say your IP address is going to be from tunnel 134. So it's going to be on that 134 network. So whatever the IP address is for the tunnel interface. So that is going to be 192.168.134.x because tunnel 134 will have that IP. So you don't need to create a loop back. You can use that tunnel IP. Tunnel source is okay. Tunnel, the network ID is okay. The redirect, I want to replace that with shortcut virtual template 134 and apply the profile 134 to it. And the last thing then you would do is your routing. Let's do this also one step at a time. So the first things first, configure your AAA part so that you can do the route set interface. This is going to be on R3, my first client. Configure my phase 1. I'll do all the way till my second step is done. Just want to make sure that everything is good. Looks good so far. All right, now I'll go over here again. Phase 2 and the IPsec profile. I'll do these two steps together. Done with that. Configure virtual template interface. IP address negotiated. This is the one that gets me the IP address from the server. And one is the IP, network ID, shortcut, protection, and then create the virtual template interface. Just to make you understand this, the tunnel interface that you see over here, it's the interface between R1 and R3. This virtual template that you see on the spoke, which you did not see before, is later on for whom? When R4 comes up, he's also going to have a tunnel interface from where? from 4 to 1. But the virtual template, this guy over here, is going to be when I want to do spoke-to-spoke communication. So this is where the virtual access will come in. It will dynamically, based on NHRP, create a tunnel between 3 and 4. That's what the virtual template is for. When this happens, when this tunnel comes up, at that point, I don't have this, the virtual template yet. Once the tunnel comes up, at that time, I have this R1, R3, and let's say R4. All part of the same network. What's the network over here? The blue network. This is going to be .1. I started the pool as 5 and 6. So 5 for the first one, 6 for the second one. So they're all on the same network. I have 10.1 over here. I have 10.3 over here. I have 10.4 over here. When I sit on R3 and I say ping 10.4.4.4, he's going to go to route 1 because he learned that route through R1. R1, based on the NHRP redirect, is going to tell him, hey, listen, in order to get there, you need to go directly to R4. And that's where the virtual template comes in and says, okay, if I get a redirect message, shortcut, use the virtual template 134. And it's going to create a virtual access directly between 3 and 4. So when the shortcut comes in, it tells it to create it based on the virtual template 134. Does that make sense? That's what it's used for. So let's copy this part over here. Okay, network ID was wrong. That's why I like doing it in small chunks, because make small typos and so you can easily rectify it and find the errors as well. Looks good now. And the last thing was routing. Now, as soon as I do routing, by the way, I need to add the 10 network over here as well. Because I need to enable that. My interface is set up with R1, and I have exchanged the routes. This is what the route set interface does. If I do show IP route, EIGRP, I have learned the 10.3 network through this new spoke-to-spoke tunnel. But at the same time, if I do just show IP route, you will notice there's a static route added over here for 134.5, which is the IP address of that tunnel interface that was assigned. That's what the route set interface does. At the same time, on R3, if I do show IP route static, you will notice that 134.1 is sent, which is again required for that NHRP. Remember, somebody asked me what was the route set command doing? That propagation of that interface IP as a static IP via this tunnel interface is what route set does. And it's required for your NHRP redirects. Good, guys? Everybody okay with this? Now, the beauty of this is once you do one site, I've done one of the spokes. Take a look at my config of my second spoke. I'll just copy the first spoke. Go to my second spoke. Let's check the config and see what changes I need to make. This is R4 now. This remains the same because everything is local. This remains the same, everything is local. It's pointing to a wildcard address of 0000, so that remains the same. The profile remains the same. My phase 2 remains the same. My iProf remains the same. My virtual template remains the same because everything is pointing towards the hub. My virtual template interface remains the same, again, pointing towards the hub, and my routing remains the same. So everything over here is identical. Copy. I'll go to router 4. So I didn't need to do any changes in my configuration that I did on R3. I can just copy and paste it onto to the other guy. And if everything is fine, should come up. Mm-hmm. Four had an issue. Clear crypto SA. What did I make a change? That is strange. Three. I'll just clear it up. Show IP route EIGRP. 5 is there. There you go. 2 is there. So 2 and 5 are okay now. Let's go to 4 and bring 4 up first. Something wrong with 4. Let's do 3. One second, let me see what's wrong with this. Okay, 3 has come up. What's wrong with 4 then? We'll bring 4 down for a second and then we'll bring it back up. It is on IOU, so sometimes it does cause an issue. Let's check that. Let's make sure that this is stabilized. Tree is good. Okay. Okay, this is good. Now let's check 4's config. Causing the issue. New model, this is okay. Route set interface is okay. On R1. Okay, there's 4 already set up. Okay, it's deleted now. So eventually it'll go away. Five is good, 2 is good, 3 is good. Now let's check 4. Copy till here. Nothing seems to be wrong. Show routing AJRP, nothing. On R1. This is gone. Make sure I'm not receiving anything over here. Good. Now let's copy it. This part looks good. Now let's move on to the profile is good. Something, it got stuck with that SA over there. That's why I was causing that issue. So show IP route EIGRP. I have 2, 3, 4, and 5. So all the config was proper. For some reason, there was one SA that was stuck with 4 and it's telling it that it already existed. So once I cleared it up, it's now okay. If I sit on 4 right now and I do show IP route EIGRP, how do you get to 3? I'm getting to 3 via 134.1. That means in order for our 4 to reach 10.3, it needs to go through this guy to come back. But what I want to do between this network is to do this. So let's do the first packet and then check what happens after that. I want you guys to focus and see that initially right now, the next hop is 134.1. So what I'll do is I'll ping 10.3.3.3. So I'm going from spoke to spoke. It'll send the packet to the hub. As soon as it sends it, I'm going to get an NHRP redirect over here. And based on that, I'm going to establish a neighbor relationship directly between 3 and 4. So now if I take a look at my show IP route EHRP, my 10.3 now is reachable directly via 192.168.134.4, which is virtual access 1. I take a look at my interface called virtual access 1, it'll go directly to 30.3. This is based on my NHRP mapping. If I take a look at my NHRP mapping, I would have a mapping for 10.3 via 34.4, which is 30.3. So I'll do a direct map 30.3. This is done through NHRP. So if I do a trace route right now, you guys remember doing this before? Remember going directly from spoke to spoke based on the redirect and the shortcuts? This is essentially the same thing, but it's just done through Flex VPN. So this config is absolutely fine. Let's save this. So today is day 5, 9-1 or 9-2, sorry. This is Flex VPN. So what type of VPNs did we take a look at right now? On the same setup, I showed you how to set up R1, connecting up to R2, using a combination of what? SVTI, DVTI, which was an IPsec point-to-point tunnel. The thing about this was one IP was dynamic. I also showed you how to set up a tunnel between what? R1 and R5, which was SVTI to SVTI. Again, IPsec point to point. But the thing about this tunnel is what? There's no dynamic IP. Both sides had static IP. And the third one that I showed you was to connect 3 to 4, where I set up a single network to connect them to each other, allowing for what? NHRP based spoke to spoke. And that's where the word flex comes in. Flex VPN allows you to have the same infrastructure, the same constructs to be utilized for what? For IPsec site-to-site, DVTI, SVTI, IPsec site-to-site using SVTI to SVTI, or IPsec with NHRP for spoke-to-spoke. Everything is done under one type of VPN. That's why the word flex comes in. If I had to do the same type of thing with the existing architecture that we've talked about, this would be your SVTI, DVTI was not there in the older setup. You had SVTI to SVTI. This used to be called DMVPN, so a completely different type of setup. So this was not even present. You would have to have different technologies to accomplish what you did with Flex VPN. So that's the advantage that you have with what? Flex, the ability to do different type of VPNs using the same type of infrastructure. whereas you would have to use different type of VPNs to do the same thing if you did not do Flex. You guys clear on that? So the VPNs that we have covered: LAN to LAN, IPsec VPN, GRE, GRE IPsec VPN, SVTI, DMVPN, Get VPN, aware VPN, VPNs using certificates, IKV2 VPNs, SVTI using legacy method and the SVTI method. Then we use Flex VPN, DVTI, SVTI, site to site. I also showed you what? SVTI to SVTI. And I showed you DVTI, SVTI using what? Spoke to spoke using HRP. So all your different type of VPNs are done. The only VPNs that are left, and we still need to do that are the VPNs under what? For firewalls. We'll do that once we get to the ASA. Everybody clear on this, guys? Is it? Shouldn't have an issue with the speed though. I am at a different location, but the speed should be proper. Let me just check the. No, man, my speeds are like 20 up, 20 down. All right, so that takes care of this portion over here. The next thing is firewalls. We'll do that after the break. So 7:22 right now, say 7:25, take a break till 7:40, 15 minutes. We come back, we start our second section, another very important one, the ASA firewalls. Any questions, guys? Everybody okay with this? All right, then let's take a break. Hey guys, give me 1 second. I need to disable my antivirus because if I don't, my GNS does not work. I'm on a new device. Now, where did I do that? Yep, right over here. All shields are off. My iOS that I'm running right now on this is my IOU is 15 dot something, 15.5, I believe. GNS depends on which one you want to run. I run 15.2 or 12.4, depending on what I want to accomplish. Right now I'm done with IOU, so I am going to stop it. So this is done. To launch my DNS and make sure it works. I'll use 3 routers over here. Oh, come on. No issues. What I'll do is after the class today, I'll upload it. Give me 1 second. I need to make sure. What is that? It is off. So all right, no worries. I'll access it on my. No, it's for the 7200, not the 3700. So what I will do over here in this case is I will access another laptop of mine. Because this is a new laptop that I bought and it has issues. It's got something to do with the antivirus. It blocks it for some reason, the GNS. So I'll access a different laptop of mine. Give me 1 second. There you go. Okay, I'll put one router over here. one on the inside and one on the DMZ. I'm going to put a firewall over here. And I am going to connect E0. Strange. Inside, outside, and this is going to go to my DMZ over here. Start my firewall. .192.1. Let's say 20.0 on the outside. This is my outside network. And I'll explain that to you guys in detail. This is my inside network. So I'll say 10.11.11.0, some internal IP. This is my DMZ network, and another internal IP, let's say 192.168.1.0. DMZ. Start the other devices now. And console in. My ASA is coming up. All right, so let's take a look at the ASA. What is the ASA? ASA is a firewall, which is by default essentially nothing more than a router, where each interface belongs to a different subnet by default. So I have this outside network configured as 20.0 right now. I have my inside network configured as 10.11.11.0 network right now. I have a third interface for my DMZ. This is generally your external network connecting towards your outside. This is generally your internal network, internal corporate network. And the DMZ is the network that you put all your public-facing servers. The servers that are accessible on the internet. Like your web server, maybe your email server to receive emails, or your relay agent. Your DNS server, if you have a public DNS server. All these are located where? On the DMZ network. Now, in ASA, although, one second. Although it is a router, but it has some different characteristics than a router does. What are the different characteristics? On a router, if this was a router by default, all traffic is allowed to go through the firewall, through the router. That means traffic from one interface to the other is allowed. Traffic from any interface to any interface is allowed by default. On an ASA firewall, the access policies are different. The default policies on a firewall, let's write them down in your notes as well. By default, it is a layer 3 device, full routing capabilities. Unlike router, the firewall does not allow all traffic to traverse through it. Okay? Traffic flow through the firewall is controlled by security levels, which are numbers of the interfaces. Each interface is assigned a security level. That's what will govern what traffic should be allowed, what traffic should be blocked. So coming back to my diagram over here, if you take a look at this over here, each interface is given a security level. By default, the security level of an interface is set to 0. So if you don't set the security level of an interface, it's going to be set to 0, except for a certain interface by the name of inside. The other thing that you also need to understand when you configure an interface on a firewall, unlike a router, it also requires these two additional capabilities. Number one is the name of the interface. It's a required parameter. Besides the name of the interface, you also are required to configure what is known as the security level of the interface. So besides your IP address and no shut, you need to do these two extra commands over here. Now, if you name your interface as inside and the interface was a blank interface, it sets a security level to 100, the highest. Any other name besides the name inside will set the security level to 0. What's the significance of the security level? On a firewall, any traffic that goes from a security level which is higher to lower is allowed by default. Low to high is blocked. So high to low is allowed by default. Low to high is blocked by default. I'm just talking about the default characteristics of a firewall. That sets it apart from a router, because a router by default allows all traffic to go through it. So when you configure an interface, you need to assign the interface besides your IP address. You need to assign the interface a name, and you need to assign an interface a security level. And the security level itself is the one that governs what traffic should be allowed and what traffic should be blocked. Does that make sense? Everybody okay with that? Understand the concept? Okay. So when you go to configure a firewall, you need to set that on the interfaces. Generally speaking, on the outside, you'll set or leave it to 0. Generally on the inside, you'll leave it at 100. Generally on the DMZ, you're going to put a value between 0 and 100, anything. 1, 5, 6, 99, doesn't matter. What I would do is I would put it in the middle, like 50. It doesn't matter though. Even 5 would be good enough, because 5 is greater than 0, less than 100. What that basically means is the inside interface can communicate to what? Either the outside or the DMZ. The DMZ can communicate to what? Send traffic, initiate traffic to the outside. But traffic coming from out towards this guy or that guy is blocked by default, or DMZ cannot access your inside. This is the default characteristic. Everybody okay with that? So when you configure the firewall, the security level plays a big part, because it's the one that controls the traffic. What about if the SL are the same? You mean the security levels are the same? Good question. What if the security levels are the same? Let's say I had router 4 over here, which have the same security level as this guy. So I have 50 and 50. The default characteristic is if two interfaces are of the same level, will not be able to communicate. At all by default. What do I mean by that? At all. When you go from low to high, what did I tell you? It's blocked. Okay? It depends on Prakash how you want to set it up. So if you go from 0 to 100, by default it's blocked, right, Brenton? But you do have the ability to go in and create an ACL which allows you to make exceptions. So you can specify that, okay, 0 to 100 by default is allowed, but I do want this traffic coming in. Or from, for that matter, from 0 to 50. Everything is blocked, but I do want to allow certain traffic, and I control it by using an ACL, by creating exceptions to the rule. Good so far? When you have the two security levels the same, they will not be able to communicate to each other even if you put an ACL. So same to same, by default, the security level, if it's the same, even the ACLs will not help you. That basically is you don't want these two guys to talk to each other at all. Good so far? So that's the same security level. Now, you do have the ability, if you want, to change that behavior. You can go from no access at all to a command that you can put in called same security level. Permit inter-interface. What does that mean? If you put this command in, it completely does a 360-degree turn or 180-degree turn. What does that mean? It goes from not allowing them to communicate at all, but if you put this command in, same security level, permit inter-interface, that basically allows every communication between these two interfaces without any ACL. So these are two extremes. The first extreme is they will not be able to communicate to each other even if you put an ACL. But if you do want them to be able to talk to each other, you can put this command in and it now completely reverses it. They can communicate to each other, no ACL required. Now, let me tell you both the situations where you would or where would you want to use one versus the other. Let's say this, I have two partners. Partner 2, they're VPN into your firewall from the outside. Okay, they come in two different interfaces, interface X and interface Y. I want both of them to be able to access what? The DMZ. So let's say I set this security level over here to 25. This is 50. So low to high, I would need to content the ACL to allow that traffic. At the same time, I don't want them to use you to get to each other. So I set the security level to the same so that partner A will not be able to talk to partner B through your firewall. So that's where you would set the security level to the same number, so they will never be able to talk to each other. Even if somebody by accident puts an ACL saying permit all. Makes sense? That's one situation. Good so far? Rinchen? Now, there's another situation that you can also be in where you have too many clients on the inside network. And to make it a little bit more efficient, what you do is you split the one network into two different networks. So this is sales 1 and this is sales 2. Same network. So I don't want them to be controlled. I want them to have full access to each other. So you can set them to the same security level, let's say 25 and 25 or 75, 75, because these are internal networks, right? But you don't want them to be doing any type of firewalling. So in this case, you would use that same security, actually same security traffic, not level. The command is that permit inter interface. So in that case, I'm using another implementation of it. Now, everything is allowed by default. At the same time, although everything is allowed by default, I can control it by using an ACL. You can still control by using an ACL. All right, but the default behavior is as soon as you put it in, they will be able to talk to each other without any control. You guys good with this so far? You guys understand this? So with that in mind, let's go ahead and configure this and see if it works or how it works. How do you configure it? Traffic from a high security level interface is allowed to flow to a lower security level interface by default. You could block the traffic by using an ACL. Okay? Traffic from a lower security level interface is blocked or is stopped or controlled or is filtered, is not allowed to flow to a higher security level interface by default. You could allow the traffic by using an ACL. Traffic from the same security level is completely blocked by default. Even an ACL will not help. You do have the ability to use the same security traffic permit enter interface command to allow all traffic from an interface between two interfaces with the same security level. Once this is done, all traffic is allowed by default. You could control it by using an ACL. What do you mean by position? You would first of all have a perimeter firewall, which would be on the edge, and then you would have an internal firewall that would control traffic between the internal subnets. And generally, that's how you would do it. One on the perimeter, one on the inside. Generally at the distribution layer. All right, so coming back over here, we've done that part. Now let's take a look at the interface configuration. Interface, let's say gig 0/0. Let's say this is the outside interface. Name if. Give it a name. Let's say outside. Any name that you give on a blank interface will set the security level to 0. And I'll write that down for you guys over here. Any name except for the name inside sets the security level of a blank interface to 0. Okay? If the interface already has a security level, it doesn't change it. If the name inside is used, the security level is set to 100 by default on a blank interface. Why do I stress that? I don't want you guys to believe that I can put in the name and it automatically changes the security level. It doesn't change the security level. If you already have a security level on the interface, it will not set it to 100 even if you use the word inside. It will only do it to a blank interface. Let me show you that. I go to my firewall right now. Over here. I go to my firewall right now here, and I do show run interfaces. Notice this interface is a blank interface. It does not have a security level, a name if, no IP address, and it's shut down. That's a blank interface. But if it already had a security level and you set a name on it, it doesn't change it. You understand that? Everybody okay with that? Good question. Is it case sensitive? It depends on what you use it for. Generally, it is not case sensitive. Although it is not case sensitive, it preserves the case. I'll explain that to you in detail. So for 99% of the command, it is not case sensitive, but it preserves the case. Let's take a look at that. Let's say I wanted to configure this over here. I want the outside interface, which is gig0/0, to be set with the name as outside, O capital, UTSIDE in lowercase. Okay, let's go ahead and do that. Interface gig0, which is the outside, name if O capital, SIDE in lowercase. Outside, set the security level to what? 0. Everybody see that? Here. Now, I can go ahead and set the IP address over here. .20.10, let's say, on the 20 network 10. Now, if it's a default mask, which I'm going to use, on the firewall, it does use the class mask as the default. So technically, I could do this, 20.10 and press enter. When I do 20.10 and press enter, it will take the class mask. What class network is this? It's a class C network, right? Yes, no? Okay, so it'll automatically take the default mask of 255.255.255.0. So it does give you that capability. On a router. You would need to specify it on the firewall. If you don't specify the mask, it defaults to the class mask. And I'll do no shut. Good so far? So what's the name of the interface? Outside. It is not case sensitive, but it does preserve the case. What do I mean by that? Later on, if I want to use it, I want my default gateway to be on the outside. I'll say route. When I say the default gateway command, I say route, the name of the interface, 00000000.192.1.20.2. Let's say 20.2 in my topology is router 2. So I'm saying my default gateway on the ASA is router 2. That's what the command is doing. But I want you guys to take a look at the name of the interface. How did I specify it? I specified it with outside with O lowercase. You see that? Good. So if it was case sensitive, outside O capital and outside lowercase would be two different names. Agreed? But over here, it takes a command. At the same time, I also want you guys to see this. This is what I meant by it preserves the case. You saw me type a route outside with O lowercase. If you take a look at the actual command, the way it put it in, you will notice that it has changed the O from lowercase to uppercase. So it preserved the case. It went back to the case that you set under the interface. This is called case preservation. It preserves the case, but it's not case sensitive, because if it was case sensitive, route outside would have been rejected. You guys understand it? Everybody okay with this? Fahad, does that answer your question? Now, another example of it not being case sensitive is the word inside. It sets a security level to when you use the word inside. Automatically, that's the only name. What is it set to for the word inside? Do you guys remember? Come on, type it. 100. Which one? This inside? This inside? This inside? Which one? It doesn't matter because it's not active. Any one of them. Because it's not case sensitive, it would be 100 as long as it's inside in any case. Because it's not case sensitive for the most part. Okay, so let's try it. I'll say gig 1, which is the inside interface. I'll say name if inside with I capital. You see that? So it's not inside all uppercase. It's not inside with all lowercase. It's for I capital NSIDE, right? So if you take a look at it, it's still set at 100. Makes sense, guys? Everybody okay with that? And then I can set the IP address normally. Now on the inside, if you take a look at my topology, the way I want to set it up is 10.11.11.0/24. That means it's not using a normal mask. So when I set the IP address, I cannot say that I'm using .10 as the IP of the device. If I say enter, it's going to use a mask of 8. I want a mask of 24. So I need to manually enter it. Unlike over here where I was using the default mask, I didn't need to enter it. So it reserves only for inside, outside, and DMZ interfaces, right? It reserves meaning what? The security level? No, case sensitive is for any interface. It's not case sensitive. The interface is not case sensitive. The name is not case sensitive for the most part. So for any interface, the name of the interface is not case sensitive, regardless of what, inside, outside, DMZ. Now, from the perspective of the default security level, the only one that has a default security level is for the word inside. Any form, uppercase, lowercase, all uppercase, whatever. What about the rest? The rest, anything is set to 0. Whether it's outside, DMZ, inside 1, inside 2, doesn't matter. Anything that's not inside, exact inside, is going to set it to 0. Make sense? Now, the other thing I also want you guys to be aware of, which is important. I told you it's not case sensitive, correct? And I've been saying for the most part, right? Have you noticed when I'm speaking, I'm saying for the most part? The reason for that is there are certain commands that are case sensitive in terms of the interface name. One such command that you'll be using later on is the crypto map command. You guys remember what the crypto map command does? It applies the crypto map to the interface for the VPN tunnels. Do you guys remember that? This command from the router? Well, this command, when you apply the crypto map to the interface, you say crypto map, let's say ABC, the name of the interface, the name of the crypto map, and you specify the interface name. And interface over here is case sensitive. So when you apply the crypto map command is case sensitive. So in that case, you need to make sure you put the right case. So if I'm using outside with O capital over here, I need to use outside with O capital over here. So over there, it is case sensitive. For the most part, it's not. Do you get my point? So most of the time, it is not case sensitive. It preserves the case, but for crypto map command, it is case sensitive. And you'll do that when you do the VPNs. At that time, you'll see it. But I just want you guys to see, in some cases and most cases, it's not case sensitive, but it is case sensitive in case of this command. Just remember that. So if you put the wrong case, I'll come back and say that this interface does not exist. I'll just do a pseudo one, just so that you guys can see the message. Crypto map ABC 10, let's say set here. I'm just putting something in, right? Crypto map ABC interface, I'll say outside. Okay. Notice what it says, unable to find the interface outside. Why? It is case sensitive. If I had done this, it would have been okay. This is okay. That's because I don't have a full crypto map, but it found the interface. Do you see the error changed? You understand that? So this is one of those commands that it does require it to be case sensitive. Other than that, most of the commands that you will use, it is not case sensitive. Everybody clear with this? Questions, guys? You guys are okay with this? All right, so I'll get rid of this. There's a command also over here, which is useful, clear configure, crypto map. So what it does, it goes into your config, your running config. Anywhere it sees the crypto map command, it'll get rid of it. All right, so what have I done so far in terms of the interfaces? My outside is set up. My inside is set up with the appropriate what? Security levels. Now, let's say I want to reset my interface. One of the ways you can do it is clear configure, interface gig 1, for example. What does it do? It clears up gig 1, what do you call it? Configuration. So if I go over here and do show run interface, now gig 1 is back to what? Clear. It's like the default command on the router. Good. Now I want to do this. The reason I did this is I want you guys to see something else. So let's say I'm doing this and I say name if inside. I misspell it. I didn't put the E in there. Do you guys see that? Everybody pay attention, guys. Do you see that? I did not put what? E at the end. That means I mistyped it. So it's not inside with the E. It's the one without E. What will the security level be for this interface? Because it's not inside exactly, it'll be 0. Take a look. Good. Now it's set it to 0. What if I say, oops, I made a mistake, I'll go back and set it to inside? What's the security level now? Still 0. As I've been telling you, it's only for blank interfaces. It's set up once, it's not going to change it. So if you want to change it, you need to do it manually. Now your interface will look a little proper. It doesn't have the IP address of shutdown, but at least the security level and the names are okay. So I'll set the IP address again. I'll say 10.11.11.10 with a subnet mask of this and no shut. So show run interface. I'll just do the two. Both interfaces are configured properly right now. Good. Another way of checking the interfaces is show interface IP brief. This is equivalent of that command that you guys have on the router called show IP interface brief. So this is your show IP interface brief. It's just show interface IP brief. Shows you the IP address and the status of the interface. The IP and interface are flipped on this command. Good so far? All right, brilliant. So let's do the third interface that I have on the diagram. What's the third interface on the diagram? That's my DMZ interface between ASA1 and R3. How do I do it? Interface gig, this is 2 for me. Name if, let's say DMZ. What's the security level going to be? 0. Anything that's not inside will be set to 0. So you need to change it. I'll set it in the middle to 50, but I need to do it. IP address based on my thingy over here is 192.168.1. I'm keeping them as .10s on the ASA. So .10 on the 20 network, .10 on the 10.11.11.0 network, .10 on the 192.168.1.0 network. It's /24. It's a proper mask, so I don't need to do anything. I can set it up like that and no shot. Show interface IP brief. Done. I have 3 routers surrounding it. Let's go ahead and set IP addresses on those. Router 1 is on the inside. I'll say 10.11.11.1. Should be able to ping 10.11.11.10. All right. I'll also set the default gateway on this guy to the firewall because I want to take care of the routing for right now. Router 2, interface F0/0, IP address 20.2. And I'll put the default gateway over here pointing towards 20.10. So all my routing is done. Everybody points to our firewall as its default gateway. I'll also enable telnet over here. So if I want to test something, I can do that. Copy paste it to 2 and 3. All right. So my interface config is done. Let's take a look. We'll call it flex. This one. So IP address 20.10, no shut. Interface gig 0/1. Name if inside. Everybody okay with this? I'll also put the other comments that I made over here. The interface name is not case sensitive for the most part, except for the crypto map command. It does preserve the case in case you type an interface pointer that is not exactly like the interface name. What do I mean by that? For example, if the name of the interface was outside with O capital, and I used the interface name in a command in the lowercase, it would take the command and automatically convert it to the proper case. So if I say route outside, which is the default route command, it will automatically change it to what? Notice the difference? And I demonstrated that to you guys as well. Good, everybody? So that's the interface configuration and security levels. The other thing that I also want to talk about over here is traffic flows, which is very important. So now my firewall is set. My question to you guys is, can people ping your firewall? Can people ping your firewall? I just did, didn't I? Remember when I was testing it, I was on R1, I pinged the firewall over here, I pinged the firewall over here, I pinged the firewall over here. So the answer is yes. Okay. Can they ping through the firewall? Can my traffic go through the firewall? Can my ping go through the firewall? Raza says no. I'm not saying whether it's going to be successful or not, but can I send the packet through? What traffic is allowed to go through the firewall? I did explain that to you guys. What traffic is allowed to go through the firewall? No, high to low. All traffic. So yes, your ping will go through the firewall as long as it adheres to high to low. The ping will go across. You guys are right, but I want you guys to understand what I'm saying over here. It only inspects implicitly. Implicitly means automatically. TCP and UDP traffic means whatever traffic is allowed, it checks and creates a return traffic in a stateful manner only for TCP and UDP traffic automatically. For everything else, you need to manually allow. Well, my question to you guys was it allowed to go across or not? The answer is yes, the ping will go across, it won't come back. So some of you guys did say the right thing. It won't return, it will not come back. Why would it not come back? Because it's not inspected by default. But it's allowed to go across. So what is allowed to go across through the firewall is what? High to low, allowed. Low to high, I'm talking about defaults. Blocked. Clear? Good? Everybody understand this? So by default, if I'm sitting over here, I will not be able to ping R2. Why not? My ping will go across, but when it tries to come back, because it was not inspected, it's going from what? Low to high. So it's going to be blocked. But if I try to do a telnet, which is TCP 23, from high to low, from 100 to 0, it's going to be allowed. But not only that, implicitly, automatically, it's going to be inspected. What do I mean by inspected? If my traffic is going from 10.11.11.1, going towards, let's say, router 2, my source port is some random port, let's say 29,999, going towards 23, which is telnet. It will inspect it and create a return entry, allowing what to come into what? 20.2, port number 23, should be allowed to come into 10.11.11.1 for port 2999. This inspection is done automatically and put into your state table. Everybody agree and understand this? You guys understand what I'm trying to say over here? Everybody, if you don't, please let me know, I'll explain it. Good so far, right? Let's test it. To test it, what I'm going to do is I'm going to go to router 2 and do a debug IP ICMP. So I can show you, if I do a ping to 192.20.2, I'm on router 1, just to make sure you understand this. I'm on router 1, I'm pinging 20.2, which is router 2 over here. The ping is not successful, obviously, because of the inspection, but notice the packet did come over here. It's trying to respond back to it. So what is that telling you? That the packet actually did go through from high to low. Everybody okay with this? Understood? But it's not successful because of the inspection. But at the same time, if I sit over here and I do a telnet to the same IP, I'm successful. I'm into router 2, and if I go to the firewall and I do show con, it tells me the connection. I have made a connection to what? 20.2 for port 23, and should allow the traffic to come back into 10.11.11.1. 58656 is the random port, random source port. That's the implicit TCP inspection. How about router 2? Can router 2 telnet into router 1? If I sit over here on router 2, which is down over here on the outside, can it telnet into R1? Low to high is not allowed. Let's check. Not allowed, right? Good. So how do I allow it? I create an ACL. Where do I create the ACL? On the firewall to make that exception. When I create an ACL on the firewall, let's write this down for you guys. Traffic flows. By default, all traffic from high to low is allowed. Only TCP and UDP traffic is inspected to create the return entry. Okay, so far so good. No traffic is allowed from low to high. By default, you can use the ACL to make. Now, what does the ACL look like on a firewall? It is a extended named ACL. All right. It uses a normal mask, not an inverse mask. So remember how you would allow let's say I wanted to allow traffic telnet into this guy. I wanted to allow telnet into 10.11.11.0. How would I write my ACL? Help me out, guys. How would I write my ACL if I wanted to allow traffic from, let's say, R2 to 10.11.11.0, anyone on the 10.11.11.0, on a normal router? How would I write it? Permit TCP host 10.11.11, no, sorry. Source is going to be what? 20.2. Help me out, guys. What would I write in my destination? Anyone on the 10.11.11.0 network on a router ACL. 10.11.11.0 on a router, I will write 0.0.0.255. The inverse mask. Agreed? On the firewall, you write the normal one. Not the inverse. Good so far? How about the rest of the traffic? Just like a normal ACL on a router, it's got that implicit what? Deny IP any. Clear? So let's do it. Access dash list. Let's say ABC, just the name. Permit TCP host 20.2 to network 10.11.11.0 EQ23. There's an implicit what? Deny any. So this is the only permit that's going to be allowed. Everything else will be denied. How do I apply it? ABC, access dash group, ABC, the name, the direction, inbound on what interface? Interface. Now again, notice I put the command in what? I'm pointing to the interface using what? Lowercase outside, right? When I press enter, show run, access dash group, you will notice it has changed the outside to what? It is not case sensitive, but it has changed it to the uppercase, the case preservation that I've been talking about. Good so far? Everybody okay with this? So let's test it. It was not working. Let's try it now. Boom. Good. So you get everybody okay? You understand this, right? All right. So now let me ask you this. If I sit on router 2, should I be able to ping the firewall? Let's discuss that. So on one physical interface, can we create virtual interfaces outside an DMZ interface? You mean sub interfaces? Yes, you can. Absolutely can. We'll do that when we do, what do you call it? When I do security context, I'll show you how to create sub-interfaces, but you can. So should I be able to ping my outside interface now? My ACL is allowing this traffic, denying everything else, right? So if I said on router 2, can I ping 20.10? Think about it. There's an implicit deny any. Will it block it? Why not? It'll block transit traffic. So the ACL is different on a firewall versus a router. Because on a router, if you put an ACL on the interface, it blocks the to traffic. To means to the firewall, to the router. It blocks to traffic as well as true traffic, which is the transit traffic that you're talking about. This is an ACL where? On a router. On a firewall, the ACL only blocks true traffic. It only applies to true traffic. All right? So let's write that down in your notes. It only blocks true traffic. It has no effect on true traffic. You guys understand what true traffic is? Traffic meant to the firewall. Now, what does that mean? How do I control traffic to the firewall? Does that mean the firewall is completely open, that people can actually hit the firewall for anything they want? Because the ACL is not controlling it. Absolutely. On the firewall, if you want to control traffic to the firewall, it is done by enabling or disabling a service or protocol. And the only service that's enabled by default is ICMP. That's the reason that you can ping the interface, because by default, every interface, the only service that's enabled is the ICMP service. All the other services, all the other protocols are disabled on the firewall. So the only thing that you can do that allows you to hit the firewall is ICMP. Do you understand that? So if you want any traffic to go to the firewall, you need to enable the service. The only service that's enabled by default is ICMP. And it's a per interface feature. So you need to enable, disable the features by doing it on a per interface basis. So let's say I want to block people from pinging my outside interface. How do I do it? How do I block people pinging my outside interface? Disable the ICMP service on the outside interface. How do I do it? Well, let's take a look. To control to traffic, enable or disable the service on that interface. It's a per interface type of thing. The only service that is enabled by default is ICMP on all interfaces. So controlling ICMP to the firewall. First thing I want to do is block ICMP on the outside interface completely. I don't want ICMP on the outside interface. ICMP deny any outside. What am I saying? I want to block ICMP on the outside. What's the default? Permit ICMP on all the interfaces, inside, outside, any interface. So if I put this command, I will block it. So right now, if I go over here on router 2, I can ping it. No problems. I'll disable this debugging. So I can ping it, right? 20.10 is pingable on router 2. 20.10 is the ASA. So I'll say ICMP deny any outside. So I've blocked ICMP on the outside. So now let's try it. Good so far? So you guys understand how you can control what? Traffic to the firewall. Another thing that I also want you guys to be aware of to do, this is one example. The other example, block outside from pinging the firewall. Now, if you get asked this question, this does not mean block everything on the firewall. So what you do is you be more specific, or you do this. People, you should be able to ping the outside world. So what you do in that case is you say ICMP permit ICMP echo dash reply outside. So when you put this command in, you put a single command in, it'll automatically implicitly block the rest. But before you do that, make sure you take this out. So what I'm going to do over here is this. Because right now, although they cannot ping me for sure, but at the same time, I will not be able to ping them either. Why? My ICMP echo also got blocked. So if I want my ICMP echo to come back, what I do is this. I'll get rid of this command, the one that I put in over here first. So now I should be able to ping. But at the same time, R2 will also be able to ping me. Right? Now, what I want to do over here is I'll say ICMP permit any echo dash reply outside. That means allow echo reply, permit the, again, deny the rest. So I should be able to ping now, but they will not be able to ping me. You get my point? Let's take it one step further. So now, ping, allow. Ping, blocked, right? Right now. Let's say there's 2.2.2.2. I want to block everything except for I want to allow this guy, okay. So I want one guy to be able to ping me, but block the rest. So you can also do this. I can also say ICMP permit host 20.2 echo outside. So if you take a look at your ICMP command now, it says permit any echo replies. So allow that. Permit 20.2 to do an echo to the outside. So you can keep on adding those lines, and anything that's not specified will be blocked. So now this guy should be able to do it. If I create a loop back over here, ping 20.2, sorry, 20.10 allowed. If I use a source of this guy, it's not going to work. Clear? So there's different things that you can do with the ICMP command. I want you guys to be completely aware of those traffic policies. Question, guys, everybody okay with the traffic flows over here? Only allow router 2, 192.20.2 to ping the outside of the firewall. So you guys have these as examples to work on. Permit ICMP. No, sorry, permit. This is wrong. Any echo reply, and this is host 20.2 echo outside. You guys comfortable with this? All right, so that's your traffic flows then. Any questions over here? Now let's take a look at management over here. What about management? One thing I want to see is if I have the license over here. I don't think so. Nope. One second, guys. I want to see if I can load up. Let's try it. See if it may activate it, because otherwise my SSH will not work on this one. I can show you remote management through Telnet. Let it come back up. All right, so we do have triple DES enabled. Good. So now let's do management. I have the firewall right now. I'm going through the console right now. I want to be able to do remote management of it. How do I do remote management of the firewall? So we've done this part, remote management. How do I do remote management? Either through Telnet, not required, not recommended. Clear text communication, not recommended. Does not work on a security level 0 interface at all. So even if you try it, it does not work on security level 0 interface. How do you enable it? Telnet followed by who's allowed. Let's say I want to allow it from the inside. You're enabling the Telnet service right now on the inside interface. If you want to set the Telnet password, you say passwd Cisco 123. So Telnet is enabled. So let's do that over here. Yep, telnet is show run telnet. Enable. So let's go to router 1, which is on the inside. Oops, wrong place. I went to myself. 10.11.11.10. Password is Cisco 123. I'm in the firewall. Good enough? Now, can I do telnet on the outside? Let's check. I want to do telnet on this outside interface. So I go on to my firewall, and I'll say telnet 192.1.20.0 on the outside. Click the command, show run telnet. But if I go to router 2 on the outside and do telnet to 20.0, it's not going to work. Why not? Firewall does not allow telnet traffic to a level 0 interface. Okay, so it's not even on the inside. I would not recommend it because let's say you do a show run on a firewall. Telnet is clear text, so your actual firewall config is getting propagated over a clear text communication. So somebody is running a sniffer, they can actually see your firewall config. So it's not recommended to do it. So what do? You do SSH. How do I do SSH? In order to do SSH, a couple of things that you need to do first. First of all, generate the key. So I'll say domain-name, cisco.com, crypto key generate RSA, modulus 1024, enter. It'll create the key for you. Now you can do SSH. All right. Once the key is generated, now I can enable SSH even on the outside interface. Now SSH does require a username and password. So how do I set the username and password? I don't have ACS right now. We'll do that later on, or ICE. I'll set up a username called admin. Password, let's say, is Cisco 123. This is a local database. I need to tell my SSH that you need to do authentication based on the local database because SSH requires a username password, not just a password. So the way you do that is AAA authentication, SSH console. Don't confuse console with the console port. SSH console is one word. And you specify that I want to authenticate the SSH console through the local database. Local is case sensitive, so it needs to be in uppercase. So this local points to this username and password. Now that I've done that, let me write these commands for you guys first. Encrypted communications requires a RSA key there to be generated. Okay. Also requires a username and password. So the way you do that is domain-name, whatever you want to call your domain, crypto key generate RSA modulus, let's say 1024, that generates the key. Enable SSH. I did it on my outside interface as well. You can do it on the inside, outside, any interface. Then the authentication part. So I create the username password first. And AAA authentication SSH console local. This is case sensitive, by the way. Good so far? So I think I've done this. Yeah, I've done the entire thing. Now I can tell SSH in from the outside. Remember, my telnet did not work. L stands for login. My login username is admin. The IP address is 20.10. It'll prompt for the password. Cisco 1, 2, 3. Got it? You can also do a show SSH users, I believe, or sessions, to check that this guy 20.2 is coming in. Username admin. For telnet, the command is who. Let's try to do a telnet as well from inside. So if you want to check your telnet, the command is who. All right. So that's your management. Everybody okay with that? Write that in your notes already. Yeah. Good. I think this is where we'll call it a day. I did, rather than doing routing over here, I did telnet, or not telnet, remote management. So in terms of this, where are we at right now? Even the ASA, we knocked out these three things. Questions, guys? And we also did access policies, by the way. Everybody good? Tomorrow is going to be a day off. I have a travel day tomorrow. I'm traveling tomorrow. Won't be able to do the class tomorrow. Okay. We'll continue the class on next Saturday, which is going to be the 9th. Same time. My objective, no class tomorrow yet. Objective, routing, NAT. We'll do transparent firewall. We'll take a look at redundancy. Next week, I'm planning on at least finishing off this portion over here. At least the redundancy portion I will knock out. So we won't have too much left for the following week. We'll take a look at your deep packet inspection of MPF and VPN. Doesn't take that long. And then we'll get into FTD. So the way I look at it, the week of, tentatively, week of September 9th, we'll do your ASA, complete almost everything with the ASA. The week of September 16th, I believe, we'll finish off an ASA. That's not too much. And we'll take a look at FTD. We'll finish FTD off. FTD doesn't take that long, as long as your concepts are clear, and I'll clear them for you guys. Because we'll do a lot of the lecture on these type of things already. It's just showing you how to do it in a graphical manner, which is your FTD. This is where the fun for FTD is. We'll take a look at that as well. So by the week of the September 16th, we would have knocked out the firewall and the VPN section. Then we get into content filtering with WSA and ESA. Just to give you a heads up in terms of when will be what are the different topics we covered. Good, everybody? Is there any simulator for FTD? No, there's not a simulator, but you can get, if you have a Cisco account, you can download the FTD 90-day trial and use that. All right, questions for me? Everybody good? Sure, it'll probably be tomorrow. Actually, not tomorrow. I'll see if I can do it today. Otherwise, it'll be on Monday because tomorrow I'm traveling. For today? You guys, if you need the videos, please send me an email. Because once this is done, I do another class. So yeah, the notes I'll just do right now. Notes I will do before I forget, because that doesn't need any rendering. First of all, Om Prakash, one of the things that I'll tell you, the thing about best practices, the best practice is to design your network based on your requirements. Every requirement is different. So take a look at your requirement rather than taking a look at a best practice. Because every network that you design will have its own small little nuances that will be different to that particular network. Take a look at it from that perspective all the time. But there's no real document that I would recommend, because what happens then is you use a cookie cutter system, which is the worst type of design that you can do. Okay. You guys tell me if you're not on this list, I'll add you guys up over here. Probably on Monday, guys, because I have another class starting right after this. And during the class, I cannot upload because that will that has an effect on my the link. And right after that, in the morning, I'm leaving. So on Monday for sure. You guys check your names. If you're not on this list, let me know. I'll put you there. Mahan, if you want to join, let me know. I'll put your name over here. You need to put your email address over here. Everybody else there, so I'll just copy it. Give me your email address, Mahan, so that I can send you the notes. Okay. Just in case you missed any of the notes, I will put them over there as well. Save. So just in case you missed any notes, they're also getting uploaded right now, including today's 9.2, 9-2. Done. All right, guys. You guys have a nice one. I'll see you guys next Saturday. Take care. Good night, guys. Take care.